Hi, the objective of this sixth video on synthetic division is to study the function print p of x. Print p of x. I'll be using the C language for this tutorial. A link in the description will take you directly to the work page. This is a work page, a wikibook. You must first download the hash files. You can find here the hash file. You can then download the first example, a C file. This is the first example, a C file. I copy this file into my editor. The first thing I must verify if I have the hash file. Yes, I have the hash file. I save my file, my C file. Can you help me to study the function print p of x? Can you help me to study the function print p of x? Yes, I can. Alors, first we can try this example. Alors, the degree of this polynomial is 2. You can find here the coefficient of the polynomial, -3, -20, 4. These coefficients are in an array. The name of this array is A. This function copy an array into a polynomial, copy an array into a polynomial. The array is A, and the polynomial, the name of the polynomial is PA. It is here. Okay. Also, I copy A into PA, and here I print a polynomial. I print P of x. In this case, P of x is PA. I print PA. Okay. Alors, this is the polynomial. This is a polynomial. You can verify the first coefficient, -3, the second coefficient, -20, and the third coefficient, 4. Okay. For example, I can put 0 for the value, for the coefficient value, for example. Now I have the new polynomial, and I don't write the constant value. Why? Because it is 0. Now I put 0 for the coefficient of x. Now I don't write never the constant value, never the x value. I only write the x power 2. Why? Because the value of x is 0 and the value of the constant value is 0. Now I put 0 for x power 2, and now I have a polynomial, the 0 polynomial. Why? Because all the values are 0. All the values are 0. Now I have put I have rewrite the coefficient, and I want to try if all work. If the file work, yes, it is correct. I want to study the function print p of x. This function is in the hash file x hash print in the hash file x hash print. Okay. Alors, the argument of this function is a polynomial. In this example, it is PA. This is a function. Okay. Alors, in first, I work on the degree. In first, I worked on the degree. Okay. This is a function. This is a code. Alors, in first, I work in the degree. Why? If the degree is 0, if the degree is 0, in first, I work on the degree. If the degree is 0, I write this. I write the coefficient without x. If the degree is 0, I write the coefficient in this way. In this way, okay? If I erase this command, degree, and else, now I have this x power 0. I don't want this type of work. It can be interesting, but not in this work. Also, I don't want x power 0. Also, I have add this line when the coefficient, the degree is 0, and I verify if the degree is 0. If the degree is 0, I don't work this type. I don't work this. I don't work it. If the degree is 0, I print directly without x. Without x. Now, if the degree is not 0, there are two types. So the degree is equal to 1, or the degree is not equal to 1. If I go here, the degree is not 0, it can be 1 or not 1. Okay? 2, 3, 4, 5, 6. If I erase this part, you can see you have the same problem you have the same problem that when the constant value x power 0. Now, if I don't work when the degree is 1, I have this type of work. I don't want this type of work. I want this type. I don't want x power 1. I don't want x power 1. Alors, it is why I must work when the degree is 1 and when the degree is not 1. Here, I verify if the degree is 0. If the degree is 0, I write the coefficient without x. It is a constant value. If the degree is 0, it is a constant value. If the degree is 1, I don't want x power 1. Also, I must write when the degree is 1 and the degree is not 1. Okay? Now, why this work? Why this type of work, because I don't want x 1x. I don't want this. I don't want 1x. I want x plus. I don't want minus 1x. I want minus x. And 3x give 3x. Okay. I don't want this. I don't want this. It is why I must write, when the coefficient is 1, I write only x. When the coefficient is minus 1, I write minus x. And else I write the value of the coefficient plus x. This is when the degree is 1. Okay? When the degree is not 1, I don't want plus 1x squared. I want plus x squared. I don't want minus 1x squared. I want minus x squared. And now, donc, I don't want this. 3x squared x 3x squared is correct. Okay? It is why I must, when the degree is not 1, I must also work when the degree is 1 and the degree is minus 1. Now I can try. I want in first write with the when the degree is 1. This is the first example. When the degree is 1, I have this type of work. When the degree is 1 and the coefficient of x is 1, it is this type of work. Okay? When the degree is 1 and the coefficient is minus 1, voilà, x minus 1. Okay? Now I rewrite the yes. No. Now I want to work when the coefficient of the x power 2 is 1. When the power of x is 1, is not 1 here, is okay, is 1. Okay. When the coefficient of x power 2 is minus 1, okay, minus 1, you don't have here 1, and now 2. Voilà, 2, okay. Alors, in first you have the degree. With this value, if the degree is 0, if the degree is 0, you print the coefficient without x. Why? Because if the degree is 0, it is a constant value. Okay? You must work when the degree is 1, because if you don't this, remember, You have x power 1. You don't want x power 1. You want x minus 20x and not minus 20x power 1. Also, you must in first work when the degree is 1 and when the degree is not 1. When the degree is not 1 and when the degree. You don't want also write x 1x. You don't want 1x. You want to write first. You want to write this in this way. You don't want to write x 1x. You don't want x 1x. You don't want write plus 1x. You don't want. Oh la 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 la. You don't want this. You want plus x. Okay. It is why you must do this code. X the coefficient is 1, the coefficient is minus 1, and the coefficient is not 1 or minus 1. It is the same thing when the degree is not 1. The degree is 0. It is this work. You work without the coefficient. It is the constant coefficient. If the degree is not 0, you must work on when the degree is 1. And now, if the degree is not 1, it is not 1 and not 0, you must write here. You want in the same way when the degree is not 1 and not 0, you work here, and when the coefficient is 1, you want this, and the coefficient is minus 1, you want this, and in the other case you write only the coefficient with x power 2, 3, 4, 5, etc. X power 2, 3, 4, 5. But when you if the polynomial is 0, first I try the example. If the polynomial is 0, this the polynomial is 0, you have this result. Okay? Now, I have deal this case with this code. Alors, the polynomial is null is true. The polynomial is null is true. Okay. The polynomial is false. Now, if I erase all the code, we deal with the null polynomial. Alors, this value, and this value. Okay. If I have erased all the code, we work on the 0 polynomial, you would not have I have write nothing. Okay. Now I have put the code, and now I have the 0 polynomial. Okay. It is this line. It is this line. We print a 0 polynomial. I erase this line. Okay. This say I have a variable I don't use. Now I re-put the line. Now I have 0. Alors. In first, I say the polynomial is null, is true. The polynomial is true. I say in first the px is null, is a 0 polynomial. Okay. If there is a coefficient is not 0, then the polynomial is not null. Polynomial is not null. If a coefficient is not 0, the polynomial is not null, so I don't print this value. Okay. If the coefficient is null, I don't this thing, and this thing is true. Why? Because it's true. It's true. And I print 0. This is the polynomial is null. Okay. Voilà. Alors, I have studied the function print p of x. I have tried to do this work in my main. I don't think if it is good for all of you. And this is the end, and this is the end of the video. Thank you.